Hello. This video is a bit of a deep dive into Onshape's Derive performance. So within Onshape, Derive is used all over the place. You use it to pull in common geometry that you then want to modify. So for an example, if you have this pattern of cubes, say, and you want to pull it into another part studio and then add holes to it, change it, somehow tweak it, you would use a derived. This is a bit of a constructed example, just because I'm just trying to test something under very controlled circumstances. So a cube is pretty much one of the simplest things you can generate in Onshape, and it's very fast to generate. So here I'm looking at the performance of generating just a single cube, and we can tweak that by saying only pattern a 1x1 cube. And my initial question here was, when I derive in this cube to another part studio, is the performance changed? Because theoretically it's no more work. In fact, it's just using these features and then pulling it in. So here's the raw part studio, and you can see we're at 14 milliseconds. And then the first derive is 127 milliseconds. So almost a 10x cost for regeneration time. Now, you might think that that's just overhead because there are additional things that need to happen in order to pull the context from that part studio into this next part studio. Maybe that's the case. So my next question was, if I keep deriving, do we see the curve kind of continue to increase as I'm deriving the derive of the derive, or does it just kind of level off? If there's a constant increase, then we should see a constant increase in the amount of time that each subsequent derive takes. Now this says 117 milliseconds, so this is a good time to bring up the fact that something that can skew these measurements is cache, because Derive does use the derive opportunity as a point to save some cache and then speed up how fast the geometry can be generated. So what I've done to avoid that is I have a configuration variable here called cache avoider, and because cache is created on a per configuration basis, if you tweak this to something that the system hasn't seen yet, then the geometry should regenerate, even though it doesn't actually impact the geometry. It's kind of it's a way to trick the system. And okay, so 127 milliseconds. And just to confirm, I'm also passing in the cache avoider into the derive property itself. Okay, so 102 milliseconds, we're still seeing slower there. And then let's just paste this in. Seeing 97 milliseconds. And we paste this in to reset it. We see 96 milliseconds. So at this point, we're deriving the derive of the derive of the derive of the original geometry. So it's kind of to the fourth power here. And then the fifth power, we see 102 milliseconds. Okay, so that's not actually too bad. And that's kind of matches historical data that I put in here. So you can see as we went through that exercise, here's some things that I've gotten in the past. And in this run, it kind of leveled off at around 300, 138, and then 300. And it actually went down on the fourth derive, which I don't understand how that's possible, but it did. And this is what we saw. So at this point, with just one cube, we don't see a continuous increase. But then when we increased to 10 cubes, and the way that I did that was just do a 2x5. A clear pattern starts to emerge. So here we see not much of a change to the original time. Actually, it only goes up to 17 milliseconds, which is reflected here. But then we see a single derive. It's multiplied by 10 roughly, or actually that's more like 5. And then we continue to see an increase. And by the time we get to the fifth derive, we're up to 415 milliseconds. So I think this isn't just because there's many different parts, but it's actually due to the fact that it just takes longer to generate this many cubes in Onshape. So somehow there's additional payment when the regeneration becomes or takes longer. And then you can actually see the pattern continues, and you pay even more of a performance cost when you have more cubes. So when there's 1,000 cubes, it only takes 373 milliseconds to generate it in the native part studio. And let's just do that just to show you. I will do roughly 1,000, so 33 times, let's say 34. And let's see, in the native part studio, it's only 430 milliseconds. But then in the first derive, we're getting up to 2.87 seconds. So that's like 5 or 6 times the half a second that we saw. And then derive squared, you can see here we're going to predict that it's around 5 or 6 seconds. And let's see what that is. Yep, 5 seconds. Derive cubed, interesting. It doesn't increase as much for the cubed case, but it should still increase. And indeed, we see 6.39 seconds. And then to the fourth and to the fifth, let's just check the fifth, jump ahead here. And we see regen times of, takes quite a bit. This is probably a good way to demonstrate how slow it can cause Onshape to be, but it takes 13 seconds. So that's quite incredible that you're paying 13 seconds to load the exact same geometry that you were able to generate in the original part studio in less than half a second. So it's about a 26x multiplier when you get to the fifth deep derive. Now this seems like a very contrived example, but it actually happens all the time if you build your logic in a very specific way, which is you kind of start with basic building blocks of how some geometry you want it to look, and then you derive those into others where you add additional features, and maybe that same basic building block is derived into other things which different features are added. So it's a pretty common pattern, especially where you want to share common components across many different parts, that we will see derives that are actually several layers deep. So my question to Onshape is why is the performance this bad, or why do you pay such a great additional cost in regeneration time when you're doing all of these derives? And how can we improve that? Thanks for listening.